I am going to graph number 11 from the homework. First thing I'm going to do is I'm going to find out if there are any x-intercepts. So to find my x-intercepts, I make y equal to 0. When I set y equal to 0, I could put 0 over 1 and cross multiply, and I get 2x equals 0 times x squared minus 1 is 0, which means x equals 0 is my x-intercept. Okay, so I'm going to plot that. All right, now I'm going to find my y-intercept. To find my y-intercepts, I make x 0. So I get 0 over negative 1, which is 0. So that's my y-intercept as well. All right, and then the last thing I'm going to find is any of my undefined values. So I'm going to set my denominator equal to 0. That's the difference of two squares. So I have a vertical asymptote at negative 1 and positive 1. Okay, I also can look for a horizontal asymptote. So if I look at my graph, the degree on the top is 1 bigger than the degree on the bottom, which means that my horizontal asymptote is y equals 0. All right, so whatever is graphed on this side of the picture is going to approach the y equals 0 horizontal asymptote. Anything on this side of the picture is going to do the same. Anything in the middle, well, I have an x-intercept and a y-intercept as 0, so I have to see how the graph is behaving in the middle. All right, so now I'm going to look for critical values to see if I have any relative minimums and maximums. All right, so let's find our first derivative. Okay, first derivative here, I have to use my quotient rule. This is 2. This is x squared. So x squared minus 1 times 2. Minus 2x times 2x. So I'm going to fix this first. I have 2x squared minus 2 minus 4x squared. So this is negative 2x squared minus 2. Combine these guys. Over g squared. Okay, so this is my first derivative. Now to find my relative extrema, I'm going to set the first derivative equal to 0. And you notice the same thing happens if I put 0 over 1. I cross multiply, I get 0 equals negative 2x squared minus 2. I'm going to add 2 to the other side. I'm going to divide by negative 2. And I get negative 1 equals x squared. When I take the square root of this, this gives me an imaginary number. So that means that I have no real critical values. So that means the only important point I have right now is x equals 0. And then these vertical asymptotes. So I'm going to use those actually to break up the graph to figure out how the graph is behaving. So I'm going to use (0), negative 1, and positive 1 to make my intervals. Okay, so from negative infinity to negative 1, I'm going to test a number. From negative 1 to 0, from 0 to 1, and from 1 to infinity. And I'm testing it into the first derivative. So let's transfer that over. All right, so let's start testing. Let me put negative 10 into this. Okay, so now when I'm testing into the first derivative, I know in any situation, no matter what I'm plugging in, the bottom's always going to be positive because I'm squaring the bottom. So the only thing I really care about is the top. So let's check out the top. I have negative 10 squared, which is 100, times negative 2. So negative 200 minus 2 over a positive number. So negative over positive is negative, which means the graph is decreasing. All right, so now I have to unfortunately pick a fractional value here. So I'll pick negative 1/2. Okay, I know the bottom is definitely going to be positive. This gives me a positive 1/4, and then it's negative 2 times positive 1/4 minus 2. So this is a negative number minus a negative number, so the top is negative. So that means that the whole thing is negative, which means that the function is decreasing. All right, now I'm going to put a positive 1/2 in. Okay, so I know the bottom is positive. And then again, I have 1/4, and then negative 2 times 1/4 minus 2. Still negative on top. So the whole thing is negative, which means the function is decreasing. All right, last one. I'll pick positive 10. I know the bottom is positive. And then again, I have 100, so negative 200 minus 2. So a negative over a positive is negative, which means the graph is decreasing. So on all my intervals, my graph is decreasing. All right, so now I'm going to sketch that. All right, so this graph has to be continually decreasing. But remember, I have a horizontal asymptote. So if my graph has to continue to go downwards, I can't be above the horizontal asymptote. I have to be below it. And I have to be decreasing. Okay, from negative 1 to 0, I'm decreasing. And from 0 to 1, I'm decreasing. So 0 is actually a point of inflection, and I could verify that in my second derivative. Okay, and then this section of the graph has to be decreasing. So the only way to be decreasing is to look like this, which means I can't be below the horizontal asymptote because at some point I'll hit my horizontal asymptote, so I have to be above it and decreasing like this.